Just give it a second.
We're going down.
Alright, can everybody still see everything? We're good to go?
Is everybody ready?
Alright, yes. Yep. Golden. Yo. That's not even an answer. But
Just woo! Are we ready? Woo!
just noises.
What does that mean? Woo!
Alright, so basically, this is only going to take about an hour. We're hoping. About an hour and 10 minutes maybe. And really this first webinar after we talked to y'all last time, which was a long time ago, I know it was 2 weeks, but it seemed like nobody had really done anything in Revit, so we figured we'd go back and add a session before we actually jumped into Revit that goes over, you know, why we're trying to tell you to talk, you know, think a certain way. And basically we've titled this Understanding Revit in order to better understand your architecture. So it's going to be everything we're telling you today can work for everybody no matter what project you're doing. So this is all about you know, how you're thinking, not as much what's going on in Revit, but we are going to go over the whole Revit interface and how that helps us create architecture. So you can keep going because there's all right, so this session is just the intro to Revit, keeping an architecture mindset while migrating into Revit, the general Revit interface and how to use it, best practices, and then the 3Ds we covered in the first one, we're going to reiterate those, and then what we'll do next time we meet. Alright, so intro to Revit. We barely hit on this last time, the industry versus the classroom, but we decided to break it into 2 more sections, which is the main aspects of Revit from an industry standpoint, and then how those same aspects are fundamentally different when you go into a studio setting. So here's the graph we showed last time, which shows you that the biggest difference is that architects stay in schematic design through most of it, but the industry will stay in construction documentation mode for the majority of the project. So when we broke this down, this is how it breaks up.
And even Revit itself seems to be laid out to be more dependent on the industry standard, which is construction documents. So much of what people use Revit for is, you know, drawing walls, drawing floors, things of that nature, versus what we spend most of our time on, which is the schematic design phase. So what we're trying to focus on in these upcoming webinars is sort of that schematic design phase and that design phase of Revit itself versus that construction document phase of just copying information.
Alright, so from an industry standpoint, you basically have Revit, whether it be Revit Architecture, Revit MEP, or Revit Structure. They're broken into 2 divisions. Most people have probably heard BIM when thinking about Revit, but there's also something called PIM. BIM is Building Information Modeling. That's basically walls, floors, and then adding details. So your sections, your floor plans, that's BIM. And then PIM is Parametric Integrated Modeling, which is everything that makes up the component of a wall. So a wall has a certain thickness, it has certain layers, whether it's, you know, studs, then sheetrock, then paint. That's making up the PIM aspect of Revit.
Yeah, and BIM, just to give a quick definition, because there's like a million different definitions about BIM. You just Google it and you'll find plenty of different explanations of what BIM is. But essentially BIM is just adding that information level to your models, and that's what Revit sort of, its strong point is that information side. But it's not just Revit, there's other programs as well. You know, you have your ArchiCAD and your Bentley. But what these do is add that information to where it's not just a wall, it's actually a wall with properties to it. It has, you know, different layers to it. It has the way it interacts with other elements. And then you have the PIM side, which means it's more about the relationships between the different elements versus just, you know, a thick wall with a bunch of different information in it. Is how that information relates to other elements. So the wall will move if you change the floors. The roof will change height if you change the heights of the walls. So everything is interrelated to each other. And that's sort of a strong point with Revit, is that it has those parametric links between different elements. And that's sort of what architecture is more about, is that parametric linking, the relationships between different elements versus just, you know, freestanding elements. So it's more about how can we start to establish, relationships between elements in Revit versus just, drawing a wall here and a floor there. But how do they actually relate to each other?
All right, so when Revit gets broken down into a studio setting, basically your two divisions, we're switching them, to suit what we need. So we're putting architecture there. There's not just two types, but architecture is going to be the controlling medium between Revit and then what we're doing in Revit. Our designs, our desires, our thoughts, our ideas. So the biggest things would be demonstrate, design, and develop, which is what we're hitting on through every one of these sessions. And then the back layer of those, kind of deeper in small letters, demonstrate would be the BIM aspect, and develop and designing would be the PIM aspect. So the industry is more focused on the BIM side, not the PIM side, and we're going to show you how to use the PIM side to further develop things from a design point, which is, it's not by any means an industry standard at all. What we're going to be doing, we're going to show you how to throw a monkey wrench in what Revit actually does throughout all of these.
Yeah, it's essentially what I mentioned before. PIM, which is more sort of more suited for a design and development, in which it's early on where you're just figuring out square footages. You're trying to see how big these spaces are. You don't want to go ahead and be putting down hard lines, which is what you typically would do on the BIM side or the demonstrate side. You have all your floor plans finished, you have that stuff finished, you're just sort of copying it into Revit. That's not what we're trying to focus on. We're trying to focus on that early phase when you're still trying to figure out how tall walls are, how slanted the roof will be, things like that. So, moving on here.
All right, so the first big point would be keeping an architecture mindset. So we're going to think like an architect while in Revit. We're not just going to say we're in a computer program, so we're going to think completely different. Everything's about a mindset. I don't care if you don't know how to use the program. If you keep a certain mindset, you will learn how to use the program. Think about what you're trying to accomplish before you start modeling. Do you ever jump into a physical model, a final physical model, without kind of knowing what you're doing? You don't. So we're going to tell you what's too soon and what's not. And then change is impossible to avoid, but to set up flexible files is easy. So we're going to show you how to set up those flexible files where when a change does occur, it occurs more fluidly than it would if you weren't thinking like this.
Yeah, so sort of that last bullet point would be that PIM, that parametric sort of side to Revit, where we're not trying to do final floor plans. We're just trying to make things work for that instance, because there are a bunch of preconceptions with what Revit can do and what it's really supposed to be used for, and that's what we're trying to blow out of the water here. Is that it's not just this final place you go to copy things into. It has that flexible side to it.
It's not just hard lines and finished product. It's everything in between, from the cruddy rough drafts we do to the final drafts.
Yeah, so lose all your misconceptions.
All right, so this is kind of long, but we'll try to break it down a little bit. Thinking like an architect, basically it's very simple to change your design in order to make it easier to model on the computer, especially when you've never used that program. I see a lot of people jump into SketchUp or ArchiCAD or Revit and not have a clue what they're doing, but they immediately start using the wall tool as a wall, and they think that a wall is always going to be a wall and the roof is always a roof, and they don't think there's any relationship between anything. So basically the points of this, thinking like an architect, if you can think it, you can model in Revit. And we firmly believe that. I would say a lot of people in the industry don't believe it, but we've proven people wrong time and time again that even the weirdest shapes can be modeled. It's just how you model them that's completely different. If you've taken this much time to come up with a concept, it shouldn't suffer when moving into a computer. How many times do reviewers or your teachers tell you that you should have stayed out of the computer? So we want to stop those comments, basically. We want the teachers to focus on the work we meant to do, not the work that accidentally happened when we jumped into the computer. And then don't change your mindset. Period. You're going to think like an architect in the computer, just like you think like an architect when you're sketching, and you think like an architect when you go outside. When you do site surveillance and you start breaking down ideas for a site, you don't think like a plumber all of a sudden. You don't think like a carpenter all of a sudden. So why would you change that mindset when jumping into a computer?
All right. Yes. So don't let the computer control your design. I mean, it's a lot of text here, and we're sort of repeating a lot of the same stuff. That's because it's pretty important for you not to sort of go to those same preconceived ideas about Revit and what you need to do when you go to it. It's all about what your design wants and what you're trying to accomplish versus what the actual program itself can do. So don't come and say, I got to change this because it doesn't work in the computer. Do your crazy design first and then try to make it work in the computer versus the other way around, putting it in the computer and then trying to make it work for your design.
This is like this basic point is, when everybody goes into Sam Flax or Dick Blick or some other art supply store, whether it be, Home Depot or Walmart that we're looking at, we have a playful mindset when looking at materials that this material can become something that it's not normally. So, I mean, wood doesn't always have to be, a structural member. It can be a sheathing. It can be a sidewalk. So take that same kind of mindset into Revit, and you're already starting off more successful than most people.
Yeah, a wall doesn't have to be a wall. A floor doesn't have to be a floor. I mean, if you take a floor and make it really skinny and tall, it becomes a wall. Of course, Revit thinks it's a floor, but it's technically a wall. Or if you have a wide wall, it could become a floor. I mean, so just because they have certain names, do not let the computer start to dictate what it wants to do.
All right, so when starting your model, I said that starting your computer model is much like any other design you start. You have to sketch ideas on paper first. This is something that, 2 years ago, I kind of would argue against. I would say, jump straight into the computer, but now that I've actually grown in Revit to the point to where I can see what its positives and negatives are clearly, I can see that there's still no computer program that you can solely design everything in. You have to have a piece of paper next to you sketching stuff. I mean, anybody that uses Revit in a studio anywhere that's good at it will have a sketchbook beside them at every point in time that they're in Revit, either to log ideas or to sketch a quick component or anything. So the most common mistake is people jump into the computer way too soon. I fully expect everybody to be able to know the program by the time we finish these sessions, and there should be no reason, why you don't completely understand it at least.
Way too soon or way too late as well.
Yeah, I mean, 2 weeks before studio pinups, finals is way too late. Way too soon is the first day the project got handed out. But the big one I'm focusing on is when is too soon. So do you have a general idea of your entire design? Have you sketched diagrams? Do you have overlays? Do you have a general concept? Yeah, a concept. Most people kind of throw that one out the window and they don't know what they're doing. And have you made any physical models at all? Because if you've answered no to any of those, you're not ready for a Revit model yet. I mean, me and Jeremy live by this. You can come by our desk and we will have either sketches, models, or both done way before we're in the computer. Now we try to finish those models and sketches a lot quicker than everybody because the faster you do get in the computer, the better the outcome. So you don't want to spend a month sketching and then 3 weeks in the computer and then 1 week in Photoshop. You maybe want to spend a week or two sketching and doing models and then jump in the computer for a month and a half and then have another week.
But there's really no hard line between when you should go and when you shouldn't go. It's really going to take you sort of practicing this and trying different things out. I mean, some people may not need a physical model. Start your computer one, or maybe what you do in the computer may change your physical model, or your physical model may affect what you do in the computer later. So I mean, it's really up to you to sort of see when is the right time for you to move to the computer.
All right, so it's a lot harder to redo an idea in the computer than it is on paper. I mean, if you sketch something and you don't like it, you can re-sketch it really quickly. We're going to show you ways in the computer that if you do change something, you can change it really efficiently. It's not necessarily going to be fast every time, but it will be efficient. Remember that physical model sketches and computer model should be coming up to the same level of completeness relatively, but that's only in the beginning to me. At first everything should kind of, your sketches should take precedent over your computer model, but at some point in time you have to say, all right, this is what I'm doing. I'm only going to develop my computer model from here on out. And then you have to go into final model stage so that you kind of know where everything's going to come up to the same place. You know where you're going to stand. You don't want to ever leave something completely behind so that you have to crunch it in at the last minute.
But that is an important point, that second bullet point, that you should be simultaneously working on your physical models, your sketches, and your computer model all at the same time.
Yeah.
they all inform each other. So you may do like some rough masses and then print those out, draw on top of those, or you may draw some stuff, scan that in, and then mouse on top of that. So I mean, it goes back and forth, which is why I say it's important for you to see when you need to go into the computer, when you need to not go into the computer. I mean, sometimes it helps a lot better to get some square masses to see square footages, scale, and print that out and use that to help you, versus taking the time to try and draw, squares or masses that represent certain square footages, when you can easily mass those up in the computer a lot quicker, and then print those out and then use those as pieces to play with. So you should be working on all three of these, all at the same time.
I mean, our big thing here is, computer modeling is not going to take the place of our drawing and physical exploration ever. Rather, it's only going to aid us to become more efficient at sketching and modeling. Like he's saying, using, overlays we printed maybe from SketchUp to start models. Using overlays we printed from, Revit to sketch over or whatever. Or to build models straight off of them. I mean, plenty of times you can print those off to scale and easily help you build a model.
Exactly, yeah. But you should still be changing stuff. You shouldn't be like, oh, this is the final computer model. I finished the sketches, I finished the models, now here's the final product right here. Let's put it into Revit. It should be, let's put it into Revit, see what happens, and then bring it back out of Revit, play with it some more, put it back in Revit. I mean, it's back and forth, so it's a mutual thing.
All right, so flexible files. That's what we're talking about with flexible files. Is your design is gonna change. Even when you think you're finished, it probably should still be changing. So you don't want to make your life more miserable by using just generic tools within any computer program and allowing yourself no room to change stuff. Basically, I put, should you use the floor, wall, and roof tool? And chances are that a wall is going to remain a wall the entire time, as slim to none. A wall could become a piece of a floor. A wall could become a piece of a roof. A wall could be your kitchen counters. It could be a lot of things, so it's not ever going to remain just a wall necessarily. So basically our fix to this is the massing tools within Revit, and we're going to really start hitting those really hard within the next 3 sessions, probably 4 sessions, because masses are so important to do when it comes to actually editing files, when it comes to the flexible files we're talking about, when it comes to getting stuck, because you can't just push and pull a wall. It's not that easy. You have to go in and edit a whole array of properties dealing with the structure of that wall. But a mass, you can just edit that mass to be whatever thickness or thinness that you want. You can cut holes in it, you can take holes out, you can twist it, you can morph it, you can do a lot of things. So we're going to hit on this lightly this session, what we're talking about, and then really dive into it next Tuesday.
Yeah, and I know a lot of what we're talking about you probably aren't too familiar with, like the wall tool and floor tool and the roof tool. But we'll be showing these later as we go and start to, sort of try to relate it back to what we've been talking about here. Is sort of some of those preconceptions that come with, floor tool or wall tool versus the massing tools. So there's a lot of text here, but
we're about to get into a lot of images really
just
fast.
Trying to get your mind right before we get into it.
Yeah, we just want you to think a certain way before we start showing stuff. And I mean, this is where we're going to start, is basically the general Revit interface. We're going to show you what's there, and then what we're going to focus on, and then show you a lot of really neat shortcuts that'll help out, and basically how to use the program efficiently. So that's what we're about to dive into for probably the next 20 minutes or so.
Yeah, so this should bring you into sort of some of the basics of just getting the program started and some of the different interfaces. When you first open the program, you'll see this window here, which is, it has a picture of your recent files. It has, sort of your recent files you've worked on, resources. But the way we broke this up was into sort of 3 different categories: your design versus your develop versus your demonstrate. The program itself is broken up into about 3 different categories. It has your projects, which have like your wall tools, your floor tools, and things of that nature. And then you have your families, which are sort of detailed components that are placed into Revit. So like the wall is a family, roofs are a family because they have certain properties around them. But then you also have sort of unique families, like you see in this sample family. It's like a louver system that hangs off the building, or you have just a basic table. So there's simpler families, and then there's more complex families, like walls that actually have parametric parameters that link them to other elements. And then you have this third one, which is the new conceptual mass, which is technically called a family as far as the program is concerned. But what that is is sort of your design phase, which has your sort of push-pull sort of action, similar to SketchUp, but a little more detailed, and it has a lot more crazier forms than I think you could create in SketchUp. But it's also sort of less intuitive than I say a SketchUp, but it gives you more options to actually create more dynamic forms when you fully understand how the program works, which is what we're going to try to explain to you within the next coming sessions. So your projects are sort of your predefined elements, and then you have your custom components, which is your families, and then you have sort of your push-pull early studies and your new conceptual mass. So this is the first screen you'll ever see when you open the program. So number 3, which is your conceptual mass interface. Every different, sort of interface I explained here has a different sort of toolbar when you open it. Your conceptual mass interface is sort of based off sort of a sketching interface versus your projects, which has your wall tool or your floor tool. But in conceptual massing, it works a little more like an architect would, with sort of sketching out different shapes and then turning those into different masses and forms, kind of like a SketchUp. Let me just bring that up real quick, just to give you a quick idea of what that looks like. Hopefully my Revit is still up and not crashing. So here's an example of sort of my screen. So I have some recent files here, I have some recent families I've played with, and then of course the resources. I should have one already open now. Alright. So here's that 3D environment I talked about for your conceptual massing. It has sort of some reference lines that you can adjust and change. We're not going to get into all that this session. This is just sort of a basic overview. But then it has your sketching tools where you could say, let's say you wanted to mass, you would slowly click, a shape you want to start with, and just simply sketch it out here. Wow, this thing's going crazy. Let's say I wanted a rectangular shape. Place it on the surface, and then I would do something like select that shape, and then I'll say create form from that, and it would sort of create a square box mass for me.
I mean, for anybody that's used SketchUp, it's not the exact same as creating a form in SketchUp, but once you create it, it's pretty much the exact same, as push and pull handles everywhere. It's not saying, pull a surface. It's not as intuitive. You have to click the surface first and then start to push and pull it. It's not like selecting a tool first, but you can do, I think, a lot more dynamic stuff in Revit that stays within, its own flexible regions. So you can keep changing stuff really quickly and have different iterations in a very short period of time that you can't have in SketchUp. I mean, even people that have used SketchUp for 5 and 6 years, since SketchUp got big, still can't create some of the dynamic masses that are created in Revit. And like Jeremy said, they're not as intuitive, but once you learn to use them, they're just as easy to use.
Yeah, and we're going to explain sort of how these work in later sessions. But if you see here, there's only a few tabs when you're in the conceptual massing environment. They all look extremely similar to each other, but fundamentally they have a few differences to them, such as the tabs have different buttons on them, things of that nature. But they're pretty similar, except for the way you create masses and create forms and create walls and roofs. So there's a conceptual massing interface, which is what we're going to be getting into in the following weeks. So let me take you to PowerPoint. So there's that. It has mostly just drawing tools. There's no like wall tool or anything like that. And that's your sort of design phase. And then you go on to number 2, which is your family interface, which these are sort of unique components that you can place into your projects. And in your family interface, it works a little bit differently, to where it has defined shapes. It has sort of like a Form Z, where you have sort of extrusions, blends, revolves, sweeps. Versus in your conceptual massing, they're all sort of intuitive. I'll show you that later, how they're intuitive. You kind of have to know how to make them, but once you start making them, you start to get the hang of it. Versus here, you sort of choose the exact shape you want to make, and then, do that basic command. So I'll just show that real quick. So here's your family. Like these all seem pretty similar, but you have to open them in different ways from that main, recent file screen.
A good way to look at these in a difference would be that your conceptual mass is for creating an idea, and a family is for completing like an actual component, like whether it be a chair or a table. Revit operates off families, period, but this is where you would go if you need to make, a one-off product for a model. Say if you're making a residential home, and the whole home is based around this repeated unit, you could come into a family mode and actually create a family, and that family could be drawn or placed anywhere inside of the modeling world.
And of course you have that parametric side as well, to where you can start to create parameters to sort of adjust the size and shape of that element that you created, which is a little more advanced, but we'll get into that as well.
Yeah, we're going to touch. This is like the three things that we're going to hit really hard in the next 3 to 4 sessions. Is the family toolbar and the conceptual massing toolbar.
And this is all stuff before you even touch, the interface we all know and love in the project environment. So these are like different, more conceptual sort of environments versus your standard, your standard project interface.
This is the one everybody's seen. But debatably, it could be one of the more important ones, because with this and the conceptual massing toolbar, you have a really powerful tool. It's really two tools separated, and you import them into each other. So you start with conceptual mass and you import it in to start detailing it. But we're going to go into this one a little bit more in detail because it has more components to it.
It's almost 3 different programs in one.
Yeah.
It has your SketchUp side, it has your Form Z side, and then it also has your Revit side, I guess, or your ArchiCAD side. Just to show you that interface. So there's that one. And then if I were to say new project, this is where it would take me into so here you see you have like a lot more buttons, because every single component has its own button. You have your curtain systems, your walls, your roofs, your floors. But then it also has a lot more tabs. Your insert, your annotate, your structure, your massing, your collaborate. So once you select a tab, it changes it and it gives you the commands for that tab.
You will end up in this part of the program, in Revit. You will spend most of your time in this portion of it, the actual portion. But you want to start with conceptual masses is what we're trying to get at. You don't want to start in this side. I mean, unless it's something really easy, like it's obvious that walls are going to be walls, but we're all supposed to be great architects, so a wall is never a wall.
So here's essentially how that interface looks. You have your design bar here, with all your sort of tools, and it changes depending on what tab you click. You have this little bar here, which actually changes depending on what tool you select. So if you select a wall, you'll have different properties for that wall. If you select a roof, it'll give you different properties for that roof to adjust here. And then you have your instance properties dialog. So if you select an element or you're on a certain screen, it'll give you the properties for that view. So right now it says floor plan level 1, so it's giving me the properties for what view I'm looking at right now, which is level 1. And you can see what view you're in at your project browser. So you have your level 1, your floor plans, your ceiling plans. So they call these plans, but technically they're just a top view with a certain cut level. I mean, that's what a level, a plan is. It's just a cut at about 6 feet above the ground, looking down. And then level 2 would be 10 feet up, and then 6 feet offset from that, and then looking down. So these each have their own sort of properties behind them, which defines where you're looking at certain times. Then you have your ceiling plan, which is you're looking up versus down, your elevations. So your different views here. Then you have your modeling space, which shows all your 3D, your model, whatever you're building at the time, it'll all show up in the model space. These little things you see here are actually your elevation tags. So north view, south view, that's what these are. These are your little views and what they're looking at. So if your model's way over here, you wouldn't see it because they're looking this way. It's just something to take note. And you have your view options. So this will change, how your view actually looks. So if you got your wireframe, things like that. Then you have your 3D space here. So if you're in 3D, you have a little cube that you can actually adjust and rotate, and it will adjust and rotate your model at the same time. You got your scroll bar, So let's keep going here and get some more slides detailing a little bit more information. So your modeling space, just a few shortcuts that we put on this slide for you to reference back to. Your middle mouse button is to pan. You have your shift plus middle mouse button to orbit. Just use your scroll mouse to zoom. And then you have your 3D views controls here to actually adjust different views. You can just click on this cube and show different views. Then you have your view options, which actually change the way your object actually looks. So let me just go ahead and bring that up. So let's say I'm just going to build something real quick. This isn't really a project or anything. So let's say I have something here. I can change the way that looks with these commands down here. Or I can adjust and move around the object by clicking on this cube here. So it's almost in the back, left, right. I can rotate it. I could use this command too to zoom in and out, things of that nature. In case you don't have a scroll mouse or something like that, you can zoom in and out. You can orbit with this as well. But if you have the shortcuts on your mouse, there's no need to use that tool. Alright. So that's your Alright. So here's just the view options, blown up. Your sun study, visibility, your scale, detail level, view styles. This is where you would change your wireframe to your shaded render, to your color drawing, to your hidden line. You have your crop region, show or hide the crop region, hide certain elements, or turn all elements back on or off with the light bulb. And one thing to take note is that this only affects the one view that you're in. So floor plan, level 1, or whatever view I'm on, these will all change for just that one view. So if I go to a different view, it all just resets back to the default, which is useful in case you want to see certain things in certain views. Let's say like a 3D view, you might want it to be shaded with shaded edges drawing, or you might want it to be a wireframe, versus another view you may want to be less detail, smaller scale. So you can adjust all the different view properties for every different view that you open. Here's a blow up the project browser. This lists all your views in the project. So if you create a new view with the view tab and you say new elevation, you draw it, it'll show up here. Okay, you do a new floor plan, new level, it'll show up here. A rendering, they show up here. So all your views, or anything you sort of create that is view specific, will show up here.
That's just one of the more self-explanatory tools. If it's any drawing, it's right there. That's pretty cut and dry.
Yeah. And whichever one is bold is actually the one that you're actually looking at the time.
All right, so properties. I want to try to speed through this a little bit faster because we're cutting up into our time pretty bad. There's two types of properties, and we're going to show you what the difference between both of them is later. But basically, it used to be that you had to right-click on your properties, like right-click a wall to go to the property section. Now you just click on it, and the properties automatically readjust. And this is how you would get to, that's the properties box you're looking at, and then you can go to edit type, and you can edit just the properties that affect that one wall, or you can affect that entire wall, so generic 8-inch, or wood stud 6-inch, or whatever it's called. The nav bar, we've kind of already showed you a little bit of that. Basically, it's really dynamic. It's going to move around. It's always going to change depending on what you're clicking or what you're trying to make. So whatever you're affecting in the modeling world, the design bar is trying to change to show you what buttons can affect that object. So a wall is not going to be affected the same way as if you clicked a chair in the model. And it's trying to help you. Sometimes it will get in the way, but in 2011, it's doing a heck of a lot better than it did in 2010.
Yeah, so if you select something, then the properties for that element will show up here. So I selected this wall, and now this changed to actually modify that wall. So now you see modifying tools versus just your standard view. Then the design bar, like I said before, if you select an element, like say you want to create a wall, and you click wall, this will change to modify that wall, and then you have the properties for that wall. So you could say I want the wall to be 20 feet tall, I want them to lock to the center point, I want to offset, a certain distance, and I want to keep them chained so they'll keep drawing them as I draw them. So all those sort of options for whatever element you select will show up on this little design bar down here. With nothing selected, it's just a blank.
And this is kind of the bottom picture is just going over what we said, that each tab contains different images, different buttons, different selections, different properties that are only specific to those tabs. So
this talks about just your view tab, which, you know, if you wanted a new section or 3D view, you would go to your view tab. And then what you also have in your view tab is your visibility graphics, which acts as sort of a filter for your entire project. So all of your ceilings and columns and curtain panels, all these things have categories. So in your visibility graphics, you can actually turn those on or off, or make them transparent, or do different things to start to filter out certain elements that you don't want to see in the project at that time. And it's just another blow up of sort of that project browser showing your different views. And your Manage tab has different things such as your project information, your parameters, diesel types, things like that. It also has sort of your snaps, which essentially they all work pretty well just as default. But if you did need to make a little shortcut, you could hit SO while you're drawing, and it'll turn them off for just that next click. In case it's snapping to things you don't want it to, you can turn it off real quick with SO. You see the shortcuts for all your snaps here. In case you want to snap to a certain thing, you can just type those in. If not, then they all default to all these different points on that line or whatever. So we'll be showing this stuff later when we're actually drawing things, but just to know where your snaps are and your materials.
some of this stuff would be good just to write down notes before next class, go in and say, you know, so if we say SO, you can kind of look at what we're doing, or if we said, you know, WA, or if we said whatever, that you kind of know what we're saying without us having to say it every single time, because a lot of it's going to be, we may use, you know, SO 14 times, and we don't want to say, all right, let's do snaps off SO every time. We don't want to say it just because of wasting a little bit too much time. But the little note at the bottom is probably the most important thing on this slide. The little double piece of paper over there in the bottom left, that no matter who uses Revit, they always tend to forget that that's there, and they end up changing a material that exists, you know, 100 times in their model. So, you know, the little asterisk, always remember to duplicate materials, and I'm going to go over it a little bit, you know, better later, what I actually mean by duplicating, what that actually does.
We'll get into materials and things and making new materials and stuff in a later session in sort of the demonstrate phase, but it's important to note that if a material's in here, it's in the project, so if you change it here, it'll change it in the project as well.
Alright, so here's some of those shortcuts we were talking about. You don't got to take note of them now, but these are the ones that, you know, we were saying, I don't use shortcuts too often. Jeremy's a shortcut guy, but these are the most used ones pretty much when you migrate back to the project, not necessarily in the conceptual massing part.
Yeah, and we'll show you how to actually change these or add new ones. It's actually really simple in 2011. And but most of the shortcuts are pretty self-explanatory. Like wall is WA, so like the first two letters of the first third or first two consonants are usually the shortcuts. So window is WN, wall is WA, snaps off is SO. I mean, they all make pretty good sense.
Yeah, it's whatever you would think it's supposed to be if you were going to shorten it to a two-letter word. It's pretty self-explanatory.
TR, line AO. So.
Keep on.
Also, if you hover over a command, it will show you, you know, what the shortcut is for that command. Typically, like walls WA, it shows you when you hover over it. So just keep note of that.
All right, so this is kind of the best practices. We hit on this a lot in the chapter we helped write, and basically we're saying best practices are, you know, masses. We want to go over why we use them now, and then in probably the next two sessions we're going to go over how to use them, so you'll actually be familiar with it. Proper material uses, you know, duplicate is what we're going to keep nailing on here. Project organization, and then naming conventions, because I'd say the last two, probably the last three, really, people really mess up when they're first getting into Revit, and that can cause so much heartache, you know, late at night, you know, 3 days, 4 days, the night before a project. So we're going to go into these a little bit more detail real quick. So you know, why are masses important? And it's kind of referred to as the SketchUp interface of Revit, like we keep saying. They provide an easy way to create and change contextual studies. See how height or thicknesses affect an entire model, not just a certain object, like you would. And if you actually went to the modeling part of Revit, you're only going to change that wall. You're not going to see how it affects everything. But But if you want to change even the slope of a roof, it's a lot harder to do once you're in a model than it is to do with a conceptual mass. You know, within a few seconds, you have a completely different contextual study. Okay, so masses can be turned into any object you want them to be turned into, whether it be a wall, roof, or a custom object you've created later on. So if you need a mass to become a wall, it very much so can be a wall. It can be a roof.
But it can't go the other way around. You can't have a wall and turn that into a mass.
Right. You can't say, oh crap, I need to edit this wall a little bit. Let me make it a mass and change it. That's why we're saying always use a mass at first. Even if you don't think you're going to need masses, go ahead and use them anyway, just out of habit. Because it's not really going to take you any more time to create the thing out of masses first and then change it into something, you know, more realistic, like walls. You don't necessarily even have to change them into walls sometimes. Sometimes just leaving them as a mass with an actual detailed layer, you know, whether it be, you know, stone or wood on top of it, will actually work, especially if you don't need detail in that section of the model. And then masses give instant feedback, unlike, you know, drawing one wall. For the overall feeling of a project, you can tell whether you're headed in the right direction or the wrong direction really quickly, much like a sketch.
Yeah, and we'll get into, you know, how to create all this stuff and how it can turn into a roof and a wall, you know, in these next few sessions, because that's what we're going to be talking about first, is massing, because that's sort of that design phase. So.
All right. So what I was saying about proper material uses, really the big thing here is to learn to duplicate everything you do. Even if you don't think that what you're editing is used anywhere in the project, because I've seen it so many times that somebody thinks they're not using a generic 6-inch wall, and then they don't duplicate it and they change that wall to be, you know, a load-bearing CMU with brick overlay wall, and then it changes, you know, 10 walls in the model, and then they're pulling their hair out trying to figure out how to get it back. And the simple answer is you can't really get it back. You can just re-edit it to be a generic wall again. So always duplicate.
Which, let me swing back to this type, and what he's talking about is because Revit works off of families, a wall is a family. So if you change that wall, it'll change all the walls, because I guess you could call them components if this was SketchUp. So if you change a component, it'll change all of them. So if you change this wall without making it a new one, without duplicating it first and saying this is my new 10-inch wall, and then making it 10 inches, it'll change all your generic walls into 10 inches. So always make sure you duplicate walls, floors, roofs, anything.
Anything, everything.
Unless you actually want to change all the 8-inch walls to 10-inch walls, then you can do that. So it works both ways, but just make sure you're aware that if you change, you know, a type, it's going to change all of them.
Just know that you are changing it. I mean, you may draw, you know, 700 walls that were generic 8 inches, and now you want them to have a brick veneer on them. Then it's going to be easier to just change that one generic 8-inch to have a brick veneer, but just know it's going to change it, you know.
But if you wanted one of those walls to have a brick veneer,
yeah, duplicate.
Make a whole new wall and then call it brick veneer wall, and then change the properties.
All right, so project organization. This is kind of like a 2-slide kind of thing. Project organization. I'm really talking about how you name things. So that's why I have another slide for naming convention. But it's basically keep things clean and organized as you go, because if you don't, you're going to be completely confused once you get multiple views in. And I've seen projects that can go from having 1 or 2 views and then all of a sudden they balloon out of control. And one good thing that I'm pointing out is sections and elevations are really helpful to plop them in and see about things as you're going. But when you're not using them, they're kind of just in your way. So you either have to hide them or delete them, and a lot of times I just delete them if it's not going to be a final drawing, because that's adding, you know, anywhere from 1 to 4 views in a single little button, and now actually 6 if you download the new stuff for Revit. But naming conventions, this is kind of a funny part. Simple do's and don'ts naming conventions that make your life a little bit easier. You know, be descriptive is the first point. Example, interior living room is at night. That's a descriptive name. Interior living room night, not 3D view 12, which is Revit's generic for like a render. It's going to say 3D view in whichever one it is, and you're not going to have a clue what that is once you get 80 renderings in a project,
yeah,
or 50
project,
rendering.
Yeah.
You're not going to have a clue. You're going to have to open up every single one of these 3D random views to figure out what's going on. And this one probably happens 100 times a year, is when people are random when they're naming stuff. example, wall 1 is not descriptive enough for you to know what wall 1 was. You have no idea. If somebody's trying to help you, they're not going to have any idea. And then my favorite, ultimate favorite, is the slam your hands on the keyboard and hope for the best, which is like L semicolon capital D 15 IE bracket. And basically these just aren't good. Don't do them, because it'll end up wasting hours of time that you don't have. Alright, so this is kind of we're starting to wrap everything back up. The importance of the 3Ds, you know, for this lesson and for the remainders of the session. Or sessions, not just this session, because we're going to keep talking about these. Okay, so the importance of the 3Ds in this session. Design is not just in the computer or with Revit, it's actually a harmony between physical modeling, sketching, and the computer model. So that's what design is when we're talking about it in this session. Development's when you start to migrate the aspects of BIM and PIM under the close guidance of you as the architect of this project. You know, you may not be called an architect now in the real world, but you're the architect of your project, whether anybody wants to believe it or not. Teachers can't take that away from you. Professors can't do anything. A professional reviewer can't do anything about that. You're the architect of your project. And then demonstration is the only true way we're going to use Revit for how Revit was created, in my mind. Obviously Revit was created in 2011 to do conceptual analysis and stuff, but it still wasn't created to perform architectural needs. It's still focusing on the construction world and the engineering world. You know, who says you have to quit thinking like an architect, basically? So we're going to show you how to demonstrate stuff like an architect still, but using the really simple tools that Revit has integrated to make this a heck of a lot easier. Little simple things like 3D sections, 3D floor plans, exploded axons can all be done really easily in Revit.
Changing colors on things, filtering things out to add emphasis. There's no reason to just export the generic plan from Revit. I mean, it's horrible.
You could take 15 minutes and make that generic plan look like an amazing, well thought out plan, even if your whole idea isn't there.
Yeah, we're trying to make this not look anything like Revit.
Right.
We all have heard teachers, you know, this is Revit, this is Revit. It shouldn't look like it's Revit. So that's what we're trying to.
And it won't eight more sessions. There's no way.
Yeah, it shouldn't look anything like it.
All right, and then basically we're just going to stay focused on these 3Ds. You know, design using Revit's massing environment to start with a general idea, and then bring that idea up to a detailed level over time. While you're developing, you're going to use the powerful tools in Revit to begin to detail models to the utmost perfection that you can achieve, while still allowing ourselves to have that flexible play that I'm talking about in the Revit environment. And then demonstrating, we're going to learn how Revit can assist us in creating amazing drawings that, you know, some people are spending hours in Photoshop creating that you can spend 20 or 30 minutes in Revit and then 5 or 10 minutes in Photoshop. You're not going to leave Photoshop, and the people that are trying to leave Photoshop and just stay in Revit are going to get lost, because you can't create every last thing, but you can create all the drawings you need.
And you can set things up in Revit to be able to work better with Photoshop.
Yeah.
So colors, things of that nature. It's easier to get out a pink background than
than
one that's mixed in with all the other elements.
There's some things like rendering. You may not want to render every last thing. You may just want to drop a lime green color behind the rendering. That way it eases your transition into Photoshop of placing that building in context. All right, so the next session we're going to jump, and I quote that because I said don't jump, into how to start a project. We're going to actually sketch to begin a design, learn how to master your designs, how to start contextual studies, and basically there's not really any homework for this, but I would love it if everybody had sketches next to them so that you can kind of be thinking about how the stuff we're doing could affect the sketch you're viewing. And it doesn't need to be a big project, or it doesn't have to be anything you do now. It could be old sketches. Or you can make up something new, you know, maybe something to boost your portfolio. Keep going.
And you could also, you know, go ahead and go over the interface, click some stuff around, try to build something, I guess, if you want to. But just open all 3 different interfaces. The conceptual maps, try to play with that a little bit, because I know you're probably not going to be able to do anything in there, but you can try to, and then because we're going to start the next class, so then you can have questions.
Yeah, we're still going to set these sessions up to the PowerPoint's basically going to be a step-by-step, and then we're going to show you some of the stuff in Revit, but we're still not going to just rely on Revit like we would in a regular classroom and then just show you everything, because that's really how people get confused, I think. But this is basically a demo of what we're going to do next class, and it'll probably be the next 2 classes because of how important masses are. This is some sketches Omar Foster did. He graduated last year, and these were his starting sketches, and this is where he ended up in Revit. Yeah, this was a semester-long project, pretty much, but that's not what Revit would be for normally. I mean, this is a good example of how he took a computer program that has a stigma on it of only being able to do houses and condominiums and really boring things. And I mean, basically this is a home built inside of a bridge, and it started with a sketch with masses, and then he started dropping in context and started detailing it. Alright, so that's the end. This was probably the shortest session we'll ever have, right at 1 hour. Does anybody have any questions, any comments, any suggestions, any critiques? Obviously next time will be probably twice this length, because we'll have to make sure everybody's, you know,
once you start doing stuff.
Yeah, everybody's starting with a mass. You know, if you are going to follow along, if you have, I say 2 monitors would probably be better if you're going to follow along, but we are going to design the PowerPoint as if you're not following along.
Yeah, we're making it to where you can take that PowerPoint after the class is over, and then do all the step-by-step by yourself at home after it's over, and then come back with questions, versus just talking the whole time and then you can't really follow along afterward. So it's going to be hopefully less text technically, but still a lot of talking.
Ruben, I'll have the video probably tomorrow. The PowerPoint's done. You know, I can do that in PDF or PowerPoint, but the video will be up probably tomorrow morning, because it's too much to edit tonight and try to get emails out. But by tomorrow morning or tomorrow at lunch, I would expect it.
Apparently the sound keeps going out.
Yeah.
Well, hopefully the recording at least will be perfect. So anything you might have missed, you can go back through it.
Yeah, the first time we did it, we recorded it as well. And even though there wasn't as many people dropping sound, there was a couple of people that still dropped sound. But the recording never dropped sound, so the recording still should be nice. And it could be your internet connection too. If your internet connection keeps phasing in and out, then it's going to keep dropping us. So that's why we're trying not to do anything else on our network at home at all. So, because if we lose y'all, that's worse than y'all losing us.
The screen was catching a little.
The screen was catching a little? You mean like lagging?
Like a lag?
There should be like a 2 to 3 second lag. And I think a lot of it has to do with we can't move the mouse around in circles and stuff like that, because that's stuff that y'all screens are having to load. But you're not really seeing. You're just going to see the mouse jerking.
We'll try to go a lot slower too when actually modeling stuff, to make sure the lag doesn't hurt too much.
We're fun to listen to. Two deep vocaled guys trying to talk. Maybe it's our voices cracking because we've been talking for an hour.
It's probably me cracking. That's what it is.
Yeah, I hit puberty twice. That's why I kept having to stop talking.
The sound's going out.
But I do want people to take note of my Skype account, because when we get into stuff and somebody has an issue, they'll be able to Skype me instead of on here, and they'll be able to show me what their issue is. Or if you want to talk directly to me over posting stuff to everybody, like maybe something's happening that you don't want to tell everybody in the world, like a stupid question that you may not think everybody else wants to hear. So write down my Skype account. The Skype's free.
Yeah, if you're able to actually have like 2 monitors where you could work on one and see the other on the other, and then then show screenshots of what you're working on and have us answer those questions. We could even wait till after the session's over.
All right, I know you have secrets to keep, Stephanie. All right, there's my Skype account.
We might be able to spend the last 30 minutes of class just going over people's problems.
Yeah,
live, and then just.
The layout I was kind of thinking of is we can switch the microphone back and forth to people. It might be hard to switch the microphone once everybody actually gets here, because there should be 12 to 15 people in. And I've been on webinars where we have a lot more than that, and they don't run near as smooth as the ones we've had. They're a lot more jumbled up. The webinars do break up, unfortunately, especially if you have another web page, like you're on Facebook or something crazy like that. Facebook will drain all your bandwidth away from the webinar, so you kind of just need the webinar open. But there's the Skype account. We are going to try to make it more you and us, instead of us talking to ourselves, really.
Exactly. Talking at you. Some back and forth. Y'all said nothing the entire time. I wanted some questions or something. Or comments. Like, this is boring, or hurry up.
Yeah. If we're droning on, tell us to shut up and keep going.
Yeah. If some stuff is obvious, then.
Then a weirdo.
Yeah, type it. Can't
Right.
read lips.
This is by far going to be the most boring one, but
We're just trying to make sure you guys aren't coming in here with preconceived ideas,
yeah,
like everybody does.
we don't want you to come in thinking Revit's going to be open to that very first screen. We're gonna really screw. We're trying to set up a precedent, kind of a segue in between how you think Revit's used and how we're going to use it, because if we don't segue, you're going to be completely lost. I know in the sessions we did last semester, we weren't 100% completely changed over like we are now, and it still completely confused people for weeks on end that we were making masses and then turning masses into things or stuff like that, or why we kept constantly duplicating objects even though we shouldn't have, when in fact we should have. They just didn't understand.
This is really stuff that no one teaches or even talks about, really. The conceptual massing, that just came out like last year.
Yeah.
So to even be teaching it is pretty crazy.
I mean, you can try to Google stuff like this, YouTube it, for random people making videos, and I guarantee you they're not going to go over the stuff that...
There's like a few, but they don't really go in depth, and they're not going to really show you how it all connects together.
Yeah, nobody really uses the massing tools to show you how to create a finalized project. They more or less just show you how massing tools work.
And they're like, all right, moving on. Now let's get to that wall tool.
And I mean, the only thing I can say for that is if you've used SketchUp, then you pretty much know how the massing tools work. It's not that hard.
Yeah.
They're more powerful, like I said, but still not hard. Was there any other problems besides everything breaking up? Or was it mainly just the sound kept going out? Was there anybody's sound that didn't go out the whole time? Whitney, did yours go out? Steph, yours went out?
Me. Yeah,
So-
Ferris left like 3 times, so.
No, I think he just leaving because of his internet connection. I'm thinking that the time it went out was probably when we switched over to Revit, and that was because the computer kind of lagged up a little bit, and that may have actually disconnected us a little bit. But that's why we're trying to focus on the PowerPoints more than the actual software. But we are going to have live demonstrations, but it's kind of like we want to do the PowerPoint first, get it out of the way to show you what we're going to do, and then actually do it, so there can be more feedback from everyone.
We can step it back, and then at the end, ask any questions.
Yeah.
Or even during, but.
So, I mean, as far as the PowerPoint goes, does this seem like a viable option now? How we're teaching it versus how you think Revit should be taught? Or do you think we're barking up the wrong tree?
I mean, be honest.
Yeah. If y'all think we should revamp stuff, I mean,
Like, what do you want to know?
now's the time.
Yeah.
It's all good in the hood. Well, actually, it's not. You obviously have not been to the hood recently.
So she's not good in the hood.
The hood is definitely not good. It does rhyme and sound cheerful, but it's not good.
She's not good in the hood, that's for sure.
Yeah, bad hoods. I would hate to wear a hood in the summertime, actually. I bet they're hot. They live under a hood. Alright, does anybody want me to go ahead and send the PowerPoint out now? And then the video tomorrow, or would you rather me send both links at the same time?
mad at nothing. Stephanie, speak English. Both.
Stephanie, you stay in Auburn, which is less ghetto than Atlanta during the week. How are you speaking like that? That doesn't make any sense. Auburn, just white people everywhere. Well, last time I went to Auburn, there was white people everywhere.
She's the most ghetto out there.
Yeah. She started the hood in Auburn.
Yeah.
Has anybody got any questions about the next couple of sessions?
And once you go black, you don't go back.
Once you go black, ouch.
Dinner knows. We'll have to cut this from the video. All right.
All right, no, seriously. Back to being professional architects.
No, seriously, this is,
yeah, we have 15 people right now coming to this, and we said our number needed to be about 20.
Yeah.
So, that's a difference of 5.
So raise on your prices. Just kidding.
So yeah, we definitely don't want to. We definitely don't want to come back and say, all right, we need 15 more bucks from everybody. So, if you have a friend, Ruben did bring a couple people in. I'll have to give him props. He actually got 3 people to join at the very last minute.
Yeah.
None of them could actually watch the video tonight, but so
At least they want to come.
But I can back that he did have 3 people join. John Ferris has gotten a couple of people to join, so that's cool. I know Whitney had your 2 friends that we're talking about. I still haven't been able to get in touch with them at all. I tried to call one of them, and I tried to send a couple of them gay Facebook messages, but
there may be something in it for you, Stephanie, but
yeah, I got something for you if you get a couple people to come. A big old hug. I'm giving out hugs for every person that comes.
hey, she needs to pay too. No those free rides.
Yes, no sharing. Jesus, Dana.
Just kidding.
Okay, yeah, that's the one I tried to contact Whitney, was Amber, and yeah.
Yeah, no.
She called me randomly at like midnight saying she wanted to do the class, and I tried to call her back 2 days later, and she didn't pick up. So anyway, there's still a ton of folks. Like, I still have a list of 30 some odd people.
And there's about 10 people who aren't here but are taking the classes.
Yeah.
So
so she's ignoring you as well. Wow, that's a bad friend. Well, at least it's not just me, though. That's good. I felt kind of bad. See, there I am hitting puberty again. My voice just cracked. Yeah, Jamie sent me an email 3 weeks ago. She's one of the people I had on the maybes list. She sent me an email, said she was interested in the free session. I sent her the free session webinar link, and then I haven't heard from her since. But I mean, there's a lot of people. So I can even give you people you can bug. People that are on the fence. Basically, is what you need to do is tell Facebook that these things were amazing. That way people will start contacting us.
Just blow up Facebook.
But yeah, we'll send the video out and the PowerPoint out tomorrow. Yeah, I had to stop bombarding their emails and Facebook, John, because I think people are starting to ignore them. But I know money's an issue for most of them, but I mean, who knows, if we can get 50 people, we can probably give money back. That's what we're saying. Like, the 80 bucks was to cover up to 20 to 25 people, and then after that, you know, we definitely want to give some kind of incentive for y'all to bring people, to get people to pay. So, you know, if we have to, you know, refund a little bit of your money after a certain amount of people. I'm starting with hugs, though. I'm sticking to that. Even for the dudes.
guarantee a hug.
Yes.
The length you done.
If you get one person, you get a hug.
Even dudes.
You get 2 people, you get 2 hugs. And then after 3 people, we're starting to talk. So, anyway, if you have any questions or anything or comments, if you hated it, tell me you hated it. We're done, Denna. You can go.
Yeah, we're done. Everybody's dismissed.
If you want to stick around and ask us stuff, feel free. Otherwise, everybody can go.
You want some private questions?
If you want to drive over and hang out and watch a movie, feel free. All right, we thank all 6 of you that came.
Yeah, thanks for coming.
Next week, there will probably be a little bit more. All right, go get your grub on.
You get my grub on, too.
Yeah. I need to eat for my 4th time. All right, Tuesday, 7 o'clock.
Yeah.
We're going to do questions first and then jump into it.
Yeah, everybody bring one question. Play with the massing, because that's what we're going to be starting with. So play with this interface, the conceptual massing, which is located
I'm free this weekend, Denna.
here.
So if you're in town, text me or something. Yeah, I'm not free tomorrow, but I am free probably Saturday or Sunday. I'm going to watch Despicable Me one of those days, so I'll have to take a break. But yeah, just let me know.
Woo!
All right. Thanks again, everyone. We'll send this stuff out tomorrow. Adios. You can stop the recording now. Let's see, Stephanie Cat, Reuben.